winning presentation, to the second runner-up presentation, and to the third runner-up presentations. And we have again secured from Siemens a commitment for them to award the winning team. Each winning team member will receive an iPod Touch. I just received word last week before Thanksgiving that Siemens was willing to basically provide iTouches to the winning team members on the presentation. Are there any questions about kind of the final presentation and how it's going to be evaluated? So the last thing, and I would ask that all of you take note of this and discuss it with your team members, especially your remote team members. The industry evaluators have asked if they could see the presentation material a day or two before the actual event. And so we are asking all teams to have their CD or DVD prepared and submitted to my office no later than December 14th at 4:45 p.m. So basically 15 minutes before the ME office closes, we need to have a CD that is prepared and has all of this information on it. So in the past, we've had the students just bring the CD or DVD to the final presentation, but now especially the Siemens folks that are providing the iPod Touches, they have asked that they be able to see the material a day or two before the presentation so that they can do a review of that material and kind of present the winning team or select the winning team as best they can. Okay, let's now transition over and talk about midterm, do a review of that effort and kind of answer any questions that you may have. So let me start by saying that the high on the midterm was 63. The low on the midterm was 8. The average was 38 or 39. If we look at just the BYU students, because they will be kind of curved, and then each of the remote schools will have kind of their the curve that they work out with their professors. But at BYU, the high was 63, the low was 19 at BYU, and the average was a 39. If all of the remote schools were grouped together, the high on the remote schools was 60, the low was 8, and the average was 36. And so similar on the highs, similar on the average, little different on the actual low scores. So the first problem on the exam asks to list and explain the functions provided by a PLM system. This was a question kind of lifted right out of the textbook. they uh, indicated kind of three things. They indicated that it was a product definition, was one of the functions that it required, and kind of the explanation out of the text was what's given here and highlighted in yellow. It's really managing knowledge and the intellectual assets that go into the product is what the product definition is about. The second thing, product production. And this is really concerned with the physical operations that are performed to produce the product. And so there was a list of materials and equipment design, equipment ordering, and all of that kind of fell underneath that category. And then the last one was operational support, and that got into the finance, human resource, the organizational structure, the management of the company, and things like that. And so that was, if you came up with these three topics and you didn't have kind of a sentence to go along with them, you received 3 points. If you kind of had a discussion of what each of these items were, short sentence, then you should have received 6 points. Some of you locked in on only one thing, and you kind of did like product definition, but you broke it into 3 pieces. I think I've tried to be fair and probably give you 3 points, not just 2. And so I tried to err on the side of giving more points than taking points off. On the second question, it asks if you're focused on the macro level, when you're doing collaborative design, what are you really focused on? What are you concerned with? And again, this was kind of taken out of the textbook, out of one of the lectures that we had on collaborative design. And it's really focusing on the system approach. And the system approach deals with things like the system form, the system function, the system level design. Is really what does the overall system, how does it behave, how does it operate, how does it function, doing system level analysis as opposed to a part analysis. What is the overall cost of the system going to be? And then it really focused on trying to optimize the system, get the best system out there for the least amount of cost. I should maybe interject at this point. I meant to do this as we started the review. If any of you have questions or concerns on how things were scored, I will be back on Friday for the BYU students, and you're more than welcome to come in and talk to me about how I allocated grades on this. For the remote students, if you have questions, you can either email me with a I've got your test, so if you just email me with a question to look at a certain part of your exam or something like that, we can interact back and forth through email. So any questions on 1 or 2 before I go on to 3? Okay, question number 3. Here again, it was taken from our lectures. It says defend the use of a CAD kernel. I think a number of you didn't read the question very carefully, and you kind of debated as to whether IGES or STEP or whatever was better or worse. The notion was I wanted you to say, I am using a kernel, and I'm moving it from this system to another, and why am I using a kernel? Well, the reason you choose a kernel is because both systems use the same kernel. If they don't use the same kernel, there's no way you can use a kernel approach to moving the material. And so this assumed that you would pick up on the notion that both systems had to be using the same kernel. And the reason you were doing it is because a kernel transfer allows all geometry and topology to move between the two systems, even though they may have drastically different graphical user interfaces. You can, for example, move NX data very accurately and very completely to ANSYS, and the reason you can do that is because both of them use Parasolid, even though their graphical user interface is drastically different. And so the main point that I was looking for was this, and I awarded 3 points if there was that kind of discussion. And then I was looking for other things like, it maintains the Boolean operators. It doesn't maintain parametrics; those will be lost. And so you don't have a completely dumb solid. You still have some Boolean operations that you can undo or redo or modify, but any expressions or any parametrics are kind of gone. And then this was another point that you may have mentioned, that you should have picked up on. The kernel files are generally smaller because they are as compact as you can get them. They generally tend to be smaller in size than an IGES or a STEP file. And then the last thing is that I thought you may mention, we made a big deal. Hang on 1 second, somebody from BYU is calling me. I don't know whether I need to pick it up or not, but I will. Greg Jensen. Kathleen, can I call you back in a minute? I'm in the middle of giving a lecture to my students remotely, and I'll give you a ring back. Sorry about that. So we made a huge deal over copious data and how that is a very painful event. We mentioned or hinted that STEP has something similar to that, and most data exchange approaches that are not kernel-based have some kind of an area that you can throw things that you can't translate or work with. And so if you had mentioned any of these 3 items here, you would have picked up another 2 points. If you entered other stuff that I felt was appropriate or applicable, then I possibly gave you an additional point or 2 by listing other things that seemed to be relevant to defending the use of a kernel. Question number 4 was really talking about a top-down approach or bottom-up, which is better. Well, it really depends. And so I was looking for a discussion if you kind of argued that a top-down approach was better, then you needed to talk about it's really designed to be for large, complex assemblies is the reason you would do it. Top-down approach allows you to kind of capture parametrics, knowledge-based engineering. It works off of a skeletal framework. It's great for doing trade studies. It really provides a framework for control of